bus is scheduled at a certain bus stop every half an hour on the hour and on the half hour between 8 a.m. and 8 p.m. each day. The delays that inevitably occur throughout the day make the buses late. The director of the bus company claims that the time the last bus, which is scheduled to stop at 8 p.m., is late, is uniformly distributed with a maximum of 20 minutes late. It is never early. So that's going to be a rectangular distribution, like this, from 0 to 20. So if the width is 20, the height must be 1 over 20, so this is going to be 1 over 20, and of course the 0 is otherwise. We want the probability that x is less than 15. Well, we don't really need to integrate or anything like that. It's clearly going to be 15 over 20, or 3/4. And for this one, the probability that x is greater than 7 and x is less than 15 over the probability that x is less than 15, well, this is a rectangle of width 8, so that's going to be 8 over 20 divided by 15 over 20, giving us 8/15. Now this one says if the probability of x is less than k, given that x is less than k plus 2 is 0.3, we want to find k. So what we're talking about here is we've got some value here, k, so that the probability of x is less than k, given that it's less than k plus 2, that probability should be 0.3. Okay, so if we look at the probability of x is less than k, given that x is less than k plus 2, the top is x is less than k, and x is less than k plus 2, all over the probability that x is less than k plus 2. So the top would just become the probability that x is less than k, and the bottom would be the probability that x is less than k plus 2. So that would be k over 20 over k plus 2 over 20, which is just k over k plus 2. So we're being told that k over k plus 2 is equal to 0.3. So k is going to be 0.3 k plus 2. So k is 0.3 k plus 0.6. 0.7k equals 0.6. So k is going to be 6/7. Okay, so there's one more part to this question. After an investigation by a group of consultants, the model is changed to a symmetrical triangular distribution, still defined on the domain 0, 20. State the distribution. So if it's symmetrical, then the maximum point must be here at 10. So it's going to go something like this. Now, the base is 20. It's a triangle this time, so half times 20 times h must be equal to 1. So that gives me that h is equal to 1/10, or 0.1. So if we look at this one here, this is of course the origin. So, well, we can straight away put in here a 0 otherwise. And then we want the straight line sections. Well, this one here, rise of 0.1, run of 10, so that's going to give us a gradient of 0.01. So 0.01x, and of course the intercept is just 0. So that's going to apply for x between 0 and 10. And then for this one, because it's symmetric and this one just goes downwards, the gradient is negative 0.01. And with all the symmetries here, that would intercept here at 0.2. So plus 0.2. Of course, you can always use linear regression on your calculator using known points and things like that in order to work out these. And so that is going to be between 10, and if this one's a less than or equal to, make sure this one's a less than, and less than or equal to 20, and that does it.